At first glance, the universe seems untouchable. A vast ocean of light stretching infinitely in every direction. From our vantage point on Earth, the stars feel close enough to dream about, yet impossibly the human mind. Alpha Centauri, the closest star system beyond our sun, lies over 4 light-years away. That means the light you see tonight left that star long before your birth, before the invention of the internet, before entire civilizations had risen and fallen. Our fastest spacecraft, by contrast, would take thousands of years to arrive there. This truth is both humbling and invigorating. Speed alone cannot conquer the cosmic scale. The universe, in a very real sense, resists us. Humanity's relationship with speed has always been one of fascination and ambition. From the first sparks of fire that lit our ancestors' way, to the chariots of ancient empires, and the engines of modern spacecraft, we have always believed that faster is better. We have engineered machines that defy gravity and overcome resistance. But space demands more than ingenuity. Even our most advanced rockets, like the Parker Solar Probe, which reaches mind-bending speeds of nearly 700,000 kilometers per hour, are still painfully slow against the backdrop of interstellar distances. At that speed, reaching Alpha Centauri would take over 6,000 years. Not merely decades, not even centuries, but millennia. Entire human histories would unfold and the stars would remain just out of reach. The challenge lies in physics itself. Rocket propulsion is constrained by the laws of motion and fuel efficiency. The more mass a spacecraft carries, the more fuel it requires to accelerate, and that fuel itself adds mass. Hypothetical propulsion systems, like the proposed fusion drive or antimatter rockets, could accelerate a craft to a significant fraction of light speed. This creates a loop that cannot be fully broken, even with nuclear or antimatter engines. But even these revolutionary engines would still encounter limits imposed by mass energy, conversion, and practical engineering. Yet where engineering reaches its boundary, physics opens a door. Einstein's theory of relativity, long proven and deeply elegant, introduces the concept of time dilation. Objects moving near the speed of light experience time differently than those at rest. To an observer on Earth, a near light-speed traveler appears to move incredibly slowly through time, stretched and slowed relative to the world they left behind. To the traveler, however, distance compresses. Stars and galaxies that would otherwise take millennia to reach suddenly feel within reach. A journey across the Milky Way that would seem impossible from Earth's perspective could be completed within a single human lifetime. This is not science fiction. It is physics we can observe in practice. Satellites orbiting Earth already account for tiny relativistic effects to keep GPS systems accurate. The phenomenon is real, measurable, and it transforms the very meaning of distance. Near light speed travel allows us to reconsider not just how far we can go, but how we experience that journey. The universe becomes intimate, not in size but in temporal perspective, and yet, this possibility comes with profound consequences. A human traveling at such speeds would effectively leap into the future relative to those left behind. While decades might pass for the traveler, generations could pass on Earth. Loved ones would age, societies would evolve. The more time stretches between us and our origin, entire civilizations could rise and fall in the blink of the traveler's eye. This is the paradox of interstellar speed. The faster we go, the act of reaching distant stars becomes a journey not only through space but through time itself. Creatures tethered to the psychology of this revelation is as important as the physics. Humans are not only explorers, they are emotional, relationships, communities, and histories. Understanding the scale of the cosmos challenges our perception of meaning. What does it mean to journey thousands of light years, knowing that those we know will be gone before we arrive? It is here that science intersects with philosophy. Interstellar travel is not just a question of engineering limits. It is a meditation on what it means to be human, what sacrifices we are willing to make in the pursuit of knowledge, and how curiosity can redefine our perception of life and existence. The limits of propulsion, speed, the fastest ships humanity has ever built, like New Horizons or Voyager 1, and time are not abstract concepts. They define the practical possibilities of human life in space, are monuments of engineering triumph. Yet they are still tiny sparks against the vast darkness. They demonstrate how far we can go without bending time, and they illuminate the stark reality. Distance is not a challenge to overcome with speed alone, only by leveraging the relativistic effects of Near light speed travel can human hope to cross the galaxy in a single lifetime, a revelation scientists have only recently explored in depth. Even with these possibilities, the ethical and emotional weight of interstellar travel cannot be ignored. The universe does not yield its secrets easily. Every light year we attempt to traverse is an echo of sacrifice. Every second of acceleration near the speed of light is measured, not just in physics but in human cost. And yet, this is precisely the challenge that has propelled humanity forward for millennia. The courage to confront the impossible, to redefine the boundaries of what is possible, and to venture into realms our ancestors could never imagine. If you are captivated by these questions, if the thought of crossing the stars sparks awe in your mind, this channel exists for you. Here we explore not just physics, but the philosophy, the history, and the wonder that make these journeys meaningful. Subscribe and join us as we push the limits of human curiosity. One thought, one star, one possibility at a time. The universe may be vast, time may bend, and human life may be fleeting, but together, we can explore the questions that make existence itself.